So this was a structure pop quiz 9. You can ask your doubts if you have question 1 part A. No doubt. C, B, any doubt? C1, there's a doubt. Okay. So in C1, what we have to do, a swimming pool has a dimension of 50 times 25 times 2. The water in the swimming pool has CaCl bracket 2, concentration of 4.2 milligram per dm cube. Calculate the mass in kilogram that is required to treat the water needed to completely fill the swimming pool. So how much mass is needed? We have the concentration is given. Actually, what is this mass in a unit volume? It's like a density is given. 4.2 milligram per dm cube. It's the mass in a unit volume or density. And this is a total volume of the swimming pool. That will be the same amount of so that will give us a total volume of the total volume which we need. So if we work out the volume of the pool, so volume of the pool will multiply, like example 50 is there, times 25 times 2. So 50 times 15 to 50, it will be 2500 and the unit will be meter cube. Yeah, unit is, and what about the density is given? As you can see, the density is mass over volume. So if we need the mass or the concentration is also given in milligram per dm cube. So we can find out the mass. So if we like concentration can be mass per dm cube, mass per unit volume, or it can be moles per dm cube. So if we need the mass of the CaCl in a bracket 2, so it will be concentrations times the volume. And what is the concentration given? Concentration is given 4.2 milligram per decimeter cube. So we can convert this. That will be equals to, this will be equals to 4.2. It is milligram. So this will be 4.2. Milli means 10 power minus 3. So 4.2 exponent minus 3, it will become grams per decimeter cube. I did not convert the unit of the volume. I keep it in dm cube. Okay. And 2500 meter cube, because when we want to cancel out, we should have the same unit. 2500 meter cube. I want to convert into dm cube. How I can convert the meter cube into dm cube? If I want to convert the meter into decimeter, what I should do? So if I want, so I should multiply by 1000. Yeah. So we just multiply meter cube to dm cube. We just multiply by 1000. So this will become 2500 into 10 to the power 3. Or I can also write 2.5 exponent 6. So both it is acceptable, 2.5 into 10 to the power 6 dm cube. Now we have the concentration and we are multiplying with the volume, so which is 2.5 into 10 to the power 6. What's the answer for this? How much grams we need? Ten to the power 9? No, it's because I multiply this by 1000. So it 2500, look, 2500, I just multiply by 1000 to convert the meter cube into decimeter cube. Meter to decimeter, look, meter to decimeter multiply by 10, but it's a cube, so I multiply by 10 cube, which is 1000. So when I multiply 2500 with 1000, so this will become 2, 5, and then six zeros are there. I move the point 1, 2, 3, 4, 5, 6. So this will become 2.5 exponent 6. So what I did is I want to convert meter into deci, so I will multiply by 10. But it's a cube, so I multiply by 10 cube, which is 1000. So when you multiply this, you will get 10,500 grams. That is the mass of this substance which we need. But they ask the question in how much in kilograms. So if I want to convert this into kg, what I should do? I should divide by 1000. So 10,500 divided by 1000. So it will become 10.5 kilogram. Is it clear? This one? How much in kg we need the calcium chlorate? Any doubt in C2? No doubt? Okay. Question 2, any doubt? Discuss some aspects of a thermal stability of anhydrous nitrates of elements in group 1 and 2. Any doubt in it? So here you have to compare like thermal stability as we go down the group, it increases. And why it increases? Because the ionic radii or the size of an ion increases. So less distortion or polarization to the negative ion. So the molecule remains stable. Question 3, any doubt? Question 3, 3 part 1 and 3. Okay, I'll discuss like these parts as well. So the OH react with 2-bromo 2-methyl propane with SN1 reaction. So if it's an SN1 reaction, means it is a tertiary halogen alkane. And so in a tertiary halogen alkane, what will happen first? A bond breaking will occur, and the rate of a reaction only depends on the presence of a halogenoalkane. Uh, so this will have CH3. This will be CH3. This will be H3. This will be CH3, and it is 2-bromo 2-methyl. So there is a bromine attached to 2-bromo 2-methyl. You can attach bromine anywhere. It does not make difference. You can also attach here. So this is 2-bromo 2-methyl propane. That is first. And what will happen first? It will take both the electrons which are involved in the bonding between carbon and bromine. As a result, it produces a carbon cation, a tertiary carbon cation, more alkyl groups. Then attacking nucleophile is there. So attacking nucleophile, the OH is there with a negative charge, and it will try to form a bond with C. And you can draw this anywhere because 120 is the bond angle. So equal possibilities are there that the OH can attack from this side, or OH can attack from this side, or OH can attack from the top. All possibilities are open. If I do every bond like CH3, is it okay? Yes, that's fine if you draw all of them. If you want to draw all the bonds of carbon, hydrogen, that's also fine. Then as a result, what will the final product as the OH? Any one of them you have to show. So as a result, when the OH will be attached, usually what happen is always, so the final product we can draw like OH, we can attach CH3 is here, CH3 is here, CH3 is here, and we attach OH. This is important to draw this arrow. Arrows have marks. Like this arrow is having one mark when you draw this. And the negative charge on OH and the electrons from the oxygen forming a bond with carbon, a complete arrow. And it is very important in a mechanism to show the arrows the starting of a reaction and end of the reaction. At the last, if you want to draw the Br ion, that's fine. Partial positive signs. Yes, yes, that is also important. That's a very important thing. Like drawing the partial positive and negative, that's the first thing we have to do. Partial positive and negative. And you can write the partial symbol first and positive, and partial symbol then negative. Okay. If you draw the Br ion here, that's fine, but it is already being lost. So if you don't draw, that is also okay because it is intermediate. We did not draw the Br, and we just write the change according to the carbon rather than the Br. So how the marks are distributed usually for these questions, the marks are distributed for these, the partial positive and negative, and this complete arrow, that is 1 mark. Then that is a second mark showing an arrow from the nucleophile, and the third mark is for the final product, the structure of the final product. 2-bromo 2-methyl is a tertiary bromoalkane. Define tertiary bromoalkane. Definition of the tertiary halogenalkane, that the carbon cation is surrounded by 3 alkyl groups or 3 carbon chains. We call that as tertiary bromoalkane we want to define. So a carbon which is bonded with bromine, the carbon which is attached with bromine is surrounded by 3 alkyl groups. That is a tertiary bromoalkane. Organic compound M formed when 2-bromo-2-methyl is heated ethanolic. So if it is ethanolic or alcoholic, look, this was aqueous. If you see, because when it is reacting in aqueous, it is a substitution reaction. But when it is reacting with alcoholic, it will be an elimination reaction. So what might happen in elimination reaction? That it will form an alkene. So if we have 2-bromo, like we have this structure, 2-bromo, 2-methyl propane. This is a structure. So as a result, what will happen? The bromine will be lost from the carbon, and one of the hydrogen will be lost, either on the right or on the left, or for this one. Any one of them, the hydrogen will be lost. So, for example, if I remove hydrogen, one of the hydrogen from this one, so there will be a double bond between these 2 carbons. So this is CH3. Then we have C double bond, CH2, and then we have CH3. This will be the structure. So, or you can draw the double bond. You can also draw the double bond here as well. You can remove the hydrogen from this one. So as a result of removal of hydrogen, this will be CH2. There will be double bond C, CH3, and then CH3. Yes, we did that elimination reaction. So whenever elimination reaction happen or occur, it will form an alkene. So in the question, they mention a compound M is formed when 2-bromo-2-methyl propane is heated in ethanolic. So if it is heated in ethanolic, then it will be elimination reaction. Ethanolic means alcoholic, like a medium is alcohol. In the alcohol, the reaction happen. You have an alcohol and you heat this compound 2-bromo-2-methyl propane in the presence of OH. It can be potassium hydroxide or sodium hydroxide in alcoholic medium. When alcoholic medium, halogenoalkane react in alcoholic medium, it result in a formation of alkene. But if it was an aqueous medium, like as how we identify it's an aqueous medium, as there's a substitution reaction. As there's a substitution reaction, this give as there's a substitution reaction, so this means that the SN reaction, SN1 and SN2 reactions will take place. Question 4, any doubt? The last question. This is related to reaction of alkenes. This is an electrophilic addition reaction. No, this is not substitution. This one is electrophilic addition. This is a mechanism for electrophilic. When alkene react, alkene undergo electrophilic addition reaction. When halogenoalkane react, if we have an aqueous, it will be substitution. If it is alcoholic, it will be elimination. So here you have to show like, just recall the idea of the alkene, reaction of alkene. If I was having like hydrogen was there. Hydrogen is a non-polar bond, the bond between hydrogen atom. But when this double bond come closer to the single bond, this will be partial positive and this will be partial negative. This double bond, partial positive, attracted to, like carbon will try to form a bond with this hydrogen and the hydrogen will break the bond. So this will be H, H, H here, and then positive charge. And this hydrogen, which is having a negative charge with a lone additional electron, will form a bond and it result in a formation of alkane. This is a electrophilic addition reaction. Now the same one you have to do, you have a nitrosyl chloride, NOCl. This is partial positive, chlorine is given partial negative. So this will always attack on the partial positive. So it means we'll draw an arrow, like if the previous example, we were drawing the arrow from towards the partial positive hydrogen. Now we'll draw the arrows towards the nitrogen. Like one of the carbon, any one of the carbon will try to form a bond with this nitrogen. And chlorine will, it's a partial negative shown here. So chlorine will take both of these electron pairs, which are involved in the bonding. So we'll have C, H, H, and the nitrogen is attached with the carbon and there's a double bond like this whole together is attached, and this carbon will get a positive charge because it has lost the electron. So this carbon, which is having a positive charge, and a chlorine with an additional electron, a negative charge, is attracted towards this carbon positive. So you have to draw these electrons, and as a result we'll have a final product which is shown in the diagram. So whenever alkene react, the reaction of alkenes are electrophilic addition reactions. When a halogenoalkane react, the reactions are substitution. If we have an aqueous medium, if we have alcoholic medium, it will be elimination reaction. Is it clear, the last one?